sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. First things first, let's discuss heat, what it is before you pay for it to warm your feet. Heat is the energy that flows when atoms and molecules move. It diffuses out towards coolness. Temperature is the measurement of the average motion of these atoms and molecules in the atmosphere. So there you have it. Now the first way of transportation of heat energy is radiation, like sound waves from your radio stations filling the empty space around you. Your radiator warms you, but don't start a fire now, I warned you. Heat is going through radiation from the sun before it burns you. From 93 million miles away, to re-radiate this heat is what the earth does for you. This is survival, what this heat is going through before it rises to the sky and it's gone. So there are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Conduction, the second method on my list. You can feel it like a hot pot in your fist with the handle gripped. I bet you'd rather grab a candle lit, cause it's heat through conduction that causes this. Atoms and matter in a fixed position vibrate when heated like a pan in the kitchen. Transmit the heat energy to atoms next to them that are cooler than they are to cause equilibrium. To even out the temperature, the heat has to travel up the spoon in your tea in the morning with your bagel. It might burn your hand, but just learn the land of conduction, heat energy until you understand. The earth gains little from conduction. It's mostly radiation that helps us function and keeps us warm. It's just another way for heat to move. But now let's move on to method 3 to prove. There are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Convection is the movement of heat in liquids and gases to even out the temperature fastest. This process is called diffusion. It's a flow of particles cold and hot in a fluid. If you're not listening, then stop what you're doing, cause this is the final mode that heat can move in. And this affects you every day. It's the breeze at your back and the wind at your face. When heat reaches the earth, it rises at a rate with the air in the place, and it moves up till it cools. Trillions of molecules together make up the weather that we see on the news. It's how they measure the pressure of the air and the temperature, but convection is how it got there in the atmosphere. So don't be scared. Heat moves in three ways, so we made things clear. It's like there are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are three ways that heat can travel, but it can travel in any direction. From the sun, it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection.
Lamps right here, they heat up the tubing and the box, which heats up the water, and they also shine on the solar panel, which pumps the water through the tubing.
Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that. Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Hey, don't drop that thun-thun-dun. Don't drop that thun-thun-dun. Don't drop that thun-thun-dun.
Okay, it's the ruler, Nightmare Krieger, keep me a Ruger, pop me a hoop butt, the east where I grew up, so it's what I threw up, sicker than the might throw my food up, who cooler, no one loser.
The molecules in good conductors are close together. There is very little spaces between them. When they vibrate, they push against the molecules near them. The energy flows between them easily. The molecules in insulators are not so close together. It is harder for energy to flow from one molecule to another in insulators.
Change in temperature we saw for our model house is called the greenhouse effect. And the same thing happens with a greenhouse. So we get sunlight. The sunlight can go through the glass of the greenhouse. Some of that light is absorbed in the greenhouse, and absorption means that light is soaked up like a sponge, and that light that is soaked up like a sponge turns to heat, which is represented as the red lines. This heat cannot get out. It's trapped by the glass, and that's why even on a very cold, sunny day, it will be very, very hot inside a greenhouse. Light changes to heat, and the heat gets trapped.
And so I cry so hard when I'm lying in bed to get all what's in my head. And so I wake in the morning and I step outside and I take a deep breath and get real high and I see to the top of my lungs what's going on. And I say, hey, and he prays. Oh my God, do I pray? I pray every single day. Forever will shout. And I say,
White light is made up of all the colors of the visible spectrum. When you see white things, like the white shirt, most of the visible colors are bouncing off that object and entering your eye. When you see black things, like the black shirt, most of the visible light is being absorbed by the black object. This absorbed light then changes into heat energy, which makes the black shirt warm.
What can you tell me about the angle of incidence and the angle of reflection?
They're the same.
No, Thinky. They're equal. Oh! Sheep.
Over the hills and far away, Teletubbies come to play.
1, 2, 3, 4.
La la. Ho. Teletubbies.
didn't see. La la.
Fat dick bit. Yeah, what's the video think of that? It's definitely out.
Where have the Teletubbies gone?
Teletubbies everywhere.